Welcome back. This is our third module, module 1.1.3, and this addresses the scientific method. We're going to start by addressing how scientists think. I put here on the screen two basic ways. One way that logic and thinking works in general is deductive reasoning. And a simple way to think about this is going from a general rule to a specific example. For example, the rules of geometry were used by the ancient Greek Eratosthenes to measure the circumference of the earth. And he was amazingly close, using the general principles of geometry to address this specific example of the size of the earth. This is a reasoning of math and philosophy, deductive reasoning. A second major way of thinking is inductive reasoning. This is going from a specific example to a general principle. And this is the reasoning of experimental science. So we do an experiment, we get the results, and from the specific results of that experiment, we attempt to build a general rule, build a general theory. That would be the idea that we're going for. So those are the two basic ideas that I want you to take from this particular slide. And in general, scientists have a different way of thinking about things. And this next slide, I suppose, demonstrates that to some degree. If we look at the cartoon panel over here at the right, shows a little stick man pulling a lever and zzz, he gets zapped, sits there and smoke coming off his head. And a normal person would conclude, I guess I shouldn't do that. Now a scientist asks the question, I wonder if that happens every time, and going back to that lever. And just in case you think that this is just a cartoon phenomenon, here is what I call Exhibit A. Here is a biologist with the largest leech in the world on his arm, and he's not fearful of the leech, he's proud. And so, but scientists in general have a different way of thinking about the world to some degree. It is organized common sense, but as we all know, common sense is not nearly common enough. One other kind of factoid, just kind of a little bit of a tangent, is to talk about the concept of technology. As it says here, technology is the application of scientific knowledge to a specific task or problem. And I think it's important that you have some grasp of what technology is. It's just taking what we've learned about the world, often from science, and applying that knowledge to solve a specific problem. And so that's how it kind of relates. We're not going to specifically talk a lot more about technology, but just so you know. Now, earlier we said that one of the things that distinguishes science from other branches of knowledge is the way that the knowledge is obtained. And of course, we sometimes talk about the scientific method, but there's really no such thing as the scientific method. Rather, the scientific method is a general approach, not always specific. But I'm going to give you some steps, and you should be generally familiar with these. This is single variable analysis we're going to address later. It's one kind of science, and we'll explain it more later. So don't worry about that. Let's worry about the steps of the scientific method. The first step is that an observation of a natural phenomenon is made. And this might raise a question. Before we go out and expend time and money to answer that question, we should explore resources. Look on the internet, Google it, look in the library, find out if the answer is already known. And so we don't want to reinvent the wheel if we already know the answer. But supposing that we have an observation that is that raises a question whose answer is not known, and it's deemed to be of importance and of value to pursue that, then we would apply the scientific method in that circumstance. Next, we want to formulate a hypothesis. A hypothesis is an explanatory statement that's based on inductive reasoning about observations that address a research question and can be tested. Boy, golly, that's a mouthful. I like this definition better. A hypothesis is a testable statement that addresses a research question. And I want you to notice there are only two outcomes for a hypothesis. It can be disproved or it can be supported. It is never proved. So a hypothesis cannot be proved. And that's why there's no such thing as scientific proof. In fact, the support is a statistical probability. We say it's 95% likely that this is the case. 95% likely means 5% uncertain. And so that's why it's not proven. It's just 95% likely. Anyway, so after we formulate a hypothesis, our third step would be to make a prediction. Now, the prediction is often in the form of an if-then statement, but this is not a necessary step. It is often done, and sometimes this is applied after the fact. Step 4, however, is a critical part of the scientific method, and that is to actually do an experiment, to do a test. And this experiment must include something that is called a control, which we'll explain to you a little bit later. After you do the experiment, which results in the collection of data, then we take that data in step 5 and we analyze that data and we draw a conclusion, either supporting or disproving or refuting our hypothesis. And so if the test is unsuccessful, if we found that our hypothesis was not supported but rather was refuted, we examine why. Possibly we overlooked something or we need a better hypothesis, and then we can, with revisions, reapply the scientific method to a modified version of our original experiment. And this is the scientific method. Of course, it's Thomas Huxley, remember Darwin's bulldog, he called the scientific method organized common sense, and in a way it is. So here's an example, kind of I don't want to say a hokey example, but everyday example, not really done by a scientist. But if you go into your bedroom and you flip on the light switch and the light doesn't go on, then you construct a hypothesis as to why it didn't go on. Now, if you're trying to think, what a scientist would try to do is erect a comprehensive set of hypotheses that explains every possibility. So number one, if we went in and flipped on the light, we might say the light bulb is burned out, is one hypothesis. We might say another hypothesis is that the switch is broken, that there is a fault in the circuit. We might say that the electricity is off. And so we could test each of these hypotheses with a little mini experiment. We could replace the light bulb. We could get a circuit tester and see if the circuit is indeed good, see if the switch works. We could look and see if the electricity is on in other rooms or in the neighborhood, see if it's just our house. The circuit breaker could be flipped as another hypothesis. So there's a few there. So each hypothesis is either supported or disproved. And so that's, as I say, a very simplistic example. Now, I do want to address another term that's associated with science, and it's important that we understand this term from the context of science, because the lay public often uses the word theory in a way that a scientist never would. For example, if I went home at lunch and took a nap, and I got up after the nap to go back to work, and I discovered that my keys were not in my pocket, I might say, I have a theory that my keys fell out or in the cushions of the sofa, something like that, and I could go check. But of course, that is not a theory, that's a hypothesis. But that's the way the lay public often uses the word theories. So the correct way to use the term theory we'll discuss now. So if a hypothesis is supported by many observations and has the ability to tie many of these observations together and to integrate ideas and to build a greater understanding, then that hypothesis may achieve the status of a theory. And theories, like all scientific conclusions, are subject to revision. Remember, the conclusions of science are tentative. That was one of the characteristics of science. Theories are accepted. That's about as good as it gets in science. So theory in this sense does not mean speculation like a hypothesis or a guess. A theory is a scientific theory is a powerful integrative explanation of many hypotheses. And again, as good as it gets in science, we don't have proven concepts, we have supported hypotheses, and so that's what a theory is. And again, it is accepted. Think of the theory of gravity, the theory of evolution. These are accepted by scientists as valid explanations of the way that the world works. So that's what a theory is. And we're going to end this module now, and we'll continue on with another module a bit later. So thank you.